Everyone, and welcome once again to another video from the channel. And in this video we'll be talking about how we can build a simple calculator in AWT using Java. So let's get started. So first and foremost, I'll be using the IntelliJ IDE for developing the calculator. IntelliJ is just another IDE for building and developing Java programs, but I personally like it a lot due to its convenience, ease of use, lots of plugins that it provides. But other IDEs such as NetBeans and text editors such as VSC should do as well. So you can go ahead and download the community version from the JetBrains website if you wish to use IntelliJ. I'll be leaving the I'll be leaving the download link in the description below. So let's get started with the tutorial. Yeah. So first and foremost, what we need to do is that we need to download IntelliJ. Once IntelliJ is downloaded, go ahead to New, click on Project, and click on Java here. It's selected already. Click on New again. Call your project Calculator. New window. And our project has been created, and this is a project structure. So once our project has been created, you can go ahead to source and click on new Java class. Let's call this calculator as well. Yeah, so once once our Java class has been created, we can start writing the code to build a calculator. So the first thing that we need to do, so we'll be using AWT, right? So what is AWT? AWT stands for Abstract Window Toolkit, and it is used for GUI programming in Java. So another alternative to GUI is Swing in Java. So so AWT and Swing are two options that we can use for GUI programming in Java. AWT is the older versions, and Swing is the more latest version. It's the trend, but AWT. So let's get started. So first of all, we'll be importing all the requirements which are for building the application, which is java.awt, and let's just import all of them together so that we don't have to write each and every import, right? And so this is gray right now because the import is not being used right now. So once we write the code that which requires the code inside the library, inside the imported library, this will no longer be gray in color. So let's go ahead and so once we have imported all the libraries, we can go ahead and start writing the code. So we require two variables to perform the computations. We need our string variables as well, and we need a frame, right? Because GUI programming, we need a frame. So imagine your application as a frame, then imagine a panel onto it, then imagine the calculator text field and the buttons on it. So that is how the hierarchy goes. So we need to build all those components, right? And we need to add those components all on top of each other to build the final ready application. So so frame F, then we need to add all the buttons. So button B0, which is for 0, B2, B3, B4, B5, B8, B9. So we have buttons all the way from B1, B0, B1, B2, B3, B4, B5, B6, B7, B8 and B9. So once we have our 10 buttons here all the way from 0 to 9, the next thing that we need to add more buttons, right? For the addition button, the subtraction button, the multiplication button, and the division button, the equal to button, and the clear screen button, the clear text field button, right? When we press clear, the text field should just get cleared, right? So these are the buttons that we need to add. So let's just check if we have a add, subtract, multiplication, division, equal to, and clear. Yeah, okay, that looks right. So the next thing that we need to do is write panel P. So we need this panel, right? So we need this panel will go onto our frame. Yeah, and then we need a text field where all the computations will be visible, right? Text field T1, and we need a grid layout, correct, for our buttons. They'll be in a grid like on a calculator. And okay, this looks good. Then we need to write a constructor, and yeah, so we do that. And okay, so inside a constructor we will write the f equal to new frame, and let's just call this calculator. So this is going to be the title of our frame. And okay, and then we need to set the layout. We need items one below the other. So the text field, then the buttons below it. So it needs to be in a flow, right, from top to bottom. So we need to set the layout in a flow. So f.set layout and new flow layout. Yeah. So once this is done, we need to write it for the panel. And once we do that, then we need to write all the buttons. We need to add action listeners for all those buttons, and we need to add those. We need to yeah, so what we do is b0 equal to new button, and yeah, so, and this is just going to be 0, right? The label on the button is going to be 0, and we need to add action listener to this, so that when we click on the button, when we click on the button, an action is performed. So an action listener is required that waits for the action to be performed. So, and we just define it as this. Okay, yeah, so once this is done, okay, so b0, this needs to be done for all the buttons, right? So let's just copy paste this, and yeah, so b1, b2, yeah, so this error that we see, we'll do this all the way. This error is just because we need to implement the action listener interface, I guess. Yeah, action listener interface needs to be implemented. So once we've implemented action listener, now we have this error because it requires the action performed class. So once we do this, we need to implement methods, and once you click on implement those methods and click on OK, we see that this has been automatically generated and the errors have gone. So this is great. And once we do this, b4, b5, b6, b7, b8, b9. So once we do this all the way, b1, b2, b3, b4, b5, b6, b7, b8, and b9. Yeah, so once this is done, we just need to change these as well. This is 1, 2, 4, 5, 6, 7, 8, and 9. Yeah, so once we are done with buttons all the way from 0 to 9, now we need to add it for the addition, multiplication, addition, subtraction, multiplication, and division need to be added, right? So this is going to be add, and the label is just going to be the addition symbol. Similarly, and yeah, so once we do this, b sub, b mul, and b of div. And the division symbol. So once this is done, we need to do it again for the equal to buttons and the clear button. So the equal to button and the clear button. So once this is done, equal to, let's call this CLR, and the button is called BEQ, right? Let's just BEQ. Yeah, it's BEQ, and BCLR, BCLR. Yeah, so this is done correctly. Now the next thing, when the same thing we need to do is for the initialization and the creation of the text field, right? So new text field and 20 columns. Okay, and we need to add this text field to the frame. So f.add t1 and okay, and we need to define the new grid layout as well, right? So new grid layout, and we need a 4x4 grid layout, and we just need to add that to our panel. So okay, this looks good to go. Now we need to add all of these buttons to the panel as well, right? So we just need to do p.add b of 0 and p.add b of 1. Okay, so this is going to take long. Let's just copy paste. Okay, 1 2 3 4 5 6 7 8 9. This is add, this is subtraction button, division, multiplication, division, equal to button, and the clear button. Okay, so once this is done, we hopefully have all our buttons over on there, and now if that everything is added to the panel, we just need to add the panel to the frame, right? So yeah, so once the panel is added to the frame, we can define all the frame properties. We can set the size for the frame, set the layout. So let's set the size for the frame as 200 by 180. So this is currently a very small size that I'm setting, but you all can obviously tamper it around as you all tamper with the application as you all want. You can increase the size, change the colors. I'm just going to be creating a very rough application here, but you all can obviously customize it to your needs. This video is more about showing the functionality of how we can build the calculator using AWTs, widgets, elements, and etc. So f.set visible true, right? We need to set this as true so that obviously it's visible, and this isn't. Yeah, this is it. So f.set background, let's just set the color as light gray. Yeah, you all can obviously change those like I said earlier. And another thing about AWT is that we do not get this close application thing. As I'm going on my IntelliJ software here and I'm hovering over this button to close the software, we don't get this in AWT. So we need to specifically code for this. So the code that we'll be writing for this is f.add window listener, and in the window listener we need to add a window adapter, something called a window adapter. So once we hit enter, and it's been created for us, but we do not want a window open method, we want a window closing one. So window closing, and we wanted to just exit from the system, right? So system.exit 0. So let's just have a check here. Public void window closing window event e system.exit. Okay, this looks correct. We can test this out later, and looks like all our contents have been added successfully. So once this is done, we can and we can start coding the action perform method. So this is the really important method where we'll be writing the program to get the value of the button clicked, perform the computation, right? So here what we need to do is that we need to know which button is clicked, correct? So we'll be writing a series of if conditions and getting the source of the button click so that it knows what value to pick when that button is clicked. So B0 is the name of the button, right? But so when B0 is clicked in a variable called S3 that we are in the string variable called S3 that we had created, T1 is the get text field, and we want to get the text and store it in S3 and we want to set S4 as 0. And S5 should just be S3 plus S4, right? So once this is done, we just set t1.set text as the answer of S3 plus S4, which is S5 here. S5, correct. So S3 equals t1 dot get text, S4 equal to 0, S5 equal to S3 plus S4. This is the string, this is not the numeric value, this is a string value, so please be careful about this. And yeah, this seems good. So we need to do this for all the buttons, right? So let's just do this all the way till the 9th button. 2, 3, 4, 5, 0, 1, 2, 3, 4. Yeah, so it's done all the way till B4, B5, B6, B7, B8, B9. So B4, B5, B6, B7, B8, and finally B9. Yeah, so we are doing this successfully now, and what we need to do is we need to obviously change these values to what has to be written, right? So for when we click on B0, 0 should be displaying on the text field. So obviously here we need to have 1, here we need to have 2, 3, 4, 5, 6, 7, 8, and 9. Yeah, so this is done, and now we'll be programming the part for our further buttons, which are the add button and the subtract, the multiplication, division, and okay, so let's get started with that. So what we need to do is we need to do a similar if condition, and we need to write if e.getSource equal to b of add, which is equal to the addition button, then s1, which is a string variable, s1 dot, so we need to get the text right from the text field, and what am I doing? So we just need to write t1 dot set text, and we need to, okay, this is right, and c just has to equal to 1 here. Okay, so this looks correct for the addition button. Let's similarly do this for the rest: subtraction, multiplication, and division. So this is subtraction. So these are just indicators. These are just c is equal to 1, 2. These will be used later to know what computation is being performed. Is it addition, multiplication, division, addition? So yeah, so addition, subtraction, multiplication, and division. Yeah, so once this is done, we are good to go with our equal to button. So let's do this for equal to BEQ. Let's erase this, and yeah, so this is the important part, right? So in the variable called s2 that we had defined, we're just gonna, first of all, we're just gonna get text, which is a very important part. Yeah, we get the text, and now we make use of these c initializations that we've made. C is equal to 1, right? So c is equal to 1, n equal to integer dot parse int, and this integer dot parse int is used to convert string values to integer values. So yeah, so that's that, and this is just s1 plus integer dot parse int s1 and s2, I guess. Yeah, s2, that's right. So s1 and s2 are to be added, and we just need to set the text onto the text field, right? This answer should be visible on the text field. So text field, but this is an integer value, correct? So we need to change this to string value. So yeah, so this should do, and okay, so let's just do this similarly for the other conditions. This is equal to 2, 3 and 4, right? So if it's 2, then this should be subtraction, and if it's 3, it should be multiplying the values, correct? So multiplication. If it's 4, it should be dividing the values. So yeah, so this looks right, and now we need to do the clear buttons, correct? So yeah, so let's start with the clear button. So if e dot get source equal to clear, so this just basically means, again iterating on the same thing, if this means this just basically means that if the clear button is clicked, we know that the clear button is clicked. This is just to know if the clear button is clicked, what to do basically if the clear button is clicked. So t1 dot set text, and we just want to set the text back to nothing, right, to the default state. So it's just going to be nothing here, correct? Once this is done, we can exit our constructor, and we just write the main method tsvm, and just write okay. So we are ready to test out our calculator. This looks good to go, and we just need to add the configuration here. So this is an important step in IntelliJ, so have a careful look. If you're using have a look if you're using IntelliJ, you need to add the configuration. Click here, click on application, click on main class here. The calculator will be recognized as the main class automatically, since we have written public static void main, right? So it understands what's the main class is. And okay, we can give the name to this configuration, but we can just leave it as unnamed. We can click on apply, okay, and this play button is ready to be clicked. So let's click, and the application is building, hopefully without any errors. Yeah, so as I had said earlier, okay, so it looks like I haven't added the clear button. Okay, so let's add the clear button. Okay, right, I've added the button twice. b.add clear. Okay, so we run the code again. Just taking a little while to build, and there we go. We have our application with all the buttons created properly. We have the title here properly as we had given to the application here. Obviously the frame size is a little less right now, but you can increase it according to your needs. I had set the background as light gray, and it is light gray. And see, if we perform, let's just do 7 plus 7 instance, for instance. Yeah, that's 14. If we click on clear, it clears. Let's just do 8 divided by 2, for example. So that's 4, that's right. And if we do 7 multiplied by 7, that's 49. Yeah, so all the functional, let's just test out the division. Let's just test out the subtraction. 7 minus 7 equal to 0. Yeah, so all the functionalities of our calculator is working successfully. This is obviously not an ideal looking output, but the functionality works perfectly fine. This is just because I have not spent a lot of time customizing the look of this calculator. You all can obviously go ahead and change the size, change the color, make the buttons bigger, make the text field wider, make the design more appealing. And once again, thank you so much for watching, and please like the video, subscribe to the channel. It really motivates me to put more content like this. And yes, thank you for watching.